Okay, so after the last video crash, I tidied things up a little bit. I changed the output of the highlight of the comments to be more of a bright yellow rather than a mustard yellow. I rebuilt these. I'm using the pointer method to set. And let's play around now with int main. I create this point object. It's P1, which means it's a default constructor. That means its coordinates are 0. So if I do cout P1 x equals, and then I will do a P1 dot get x and L. And let's do the same thing for P1 with the y. Get y. Okay. Compile. Run. Let's see. This should run just fine. Don't know why. Let me compile again. Target's up to date. Building. Here we go. Okay, there we go. All right, x and y are 0. Let's monkey around with them. Let's change them. P1 dot set x. I don't know, -4. The coordinate -4. And P1 dot set y to, I don't know, a 5. And then copy paste these again. All right, compile, run. There we go, -4, -5. All right, great. So now let's deal with the overloaded method. Let's create point P2 and actually give it parameters. I don't know, 197. And let's print out the P2 components. All right, P2, P2, P2 get, P2 get, save it. All right. Oh, compile again. There we go. Okay, now all of this printing out, maybe we might need to come up with some kind of a toString. A lot of your objects have built-in toString methods. If we want to print out an object, printing it out, depending on the language, will just print out like a memory address of where it's located. So let's create other methods. I guess we can consider them accessors, but this is a toString method. So it will be, well, it's going to return a string, and we will call it then toString. All right, and make sure we include string, pound, include string. All right, so there's our method, returns a string, and let's write it. String point scope toString, and I'm going to write it all in one line. Let's return a string that says point, some point object. I'll do a /n, and in it I will say x equals, and then I will append the x, and then I'll append a new line character for the y equals, and then a y, and then append a new line. Now this is going to yell at me because I want to return a string, but I've embedded 2 integers inside that. So we have to use a string method that will convert these integers to strings. It's its own to_string, again, courtesy of the string library. To string. Okay. And so down here, instead of me always having to write these lines, I could say something like this. Cout p1 dot toString. No, toString. And I don't have to put an endl in there because there's already an endl thanks to the toString method, but we'll put an extra one just for safety's sake. Okay, save, compile, run, compile again, run. There we go. Point object. There's all the information about it. And printed nicely, one per line. So instead of having to keep doing this kind of nonsense, we have a string method. Maybe we just want to have a print method that does it instead of converting everything to a string. So in this case, we can create a print method. And what does the print method do? It's going to look a lot like the point object. So void point print, and that would be a cout. I would say point, I'll just say information. That way you don't confuse it with what's up there. Point information slash new line. I'll say x equals, and here I can print out the x. And the reason why I don't have to convert it to toString is because the cout object is smart enough to know how to cast as strings, integers, doubles, chars, whatever, depending on what's being sent to the output stream operator. Okay, new line. I'll say y equals output stream y. And sometimes it doesn't. I'm going to put it in now, the endl. But sometimes when you print or build a string and you force a new line in there, that might upset the end user, that if they want to put this inside a paragraph or something like that, well, they've just been doomed with a new line. So let me do them the courtesy of not putting that in. And so if we do a cout, no, can't do a cout, we just invoke it, p1.print. Because if you try to do a cout of a cout, you get all sorts of errors. It doesn't know how to do it. Okay, built. Come on. There we go, like that. All right, there's the new line from up here, but here we didn't give it a new line, but the output information automatically went to the next line. Good job, good job. Okay, so close all of this. Let's see what else I need to do. Oh, in C++, we have to do one last thing. We have, in these methods, we have to have a destructor. And what a destructor will do, well, here's what it looks like. Tilde point. That means the point object is destroyed. Whenever we create these objects, we want to destroy them. Maybe we're creating them using pointers, and when the pointers are no longer used or we have to reclaim the memory, you have to implicitly destroy them. Java already destroys objects when they're not used. Think about that you're writing a game and you blast some fireball and the fireball goes out of scope. Well, when it's out here, it's not used anymore. You better destroy it when it goes out of its coordinates. If not, you're going to have all these fireballs out here in negative void infinity, and it's going to slow down your game. So what we want to do is implicitly destroy things. In this case, we're going to implicitly destroy the point. So we're going to write it. Now, here, it's just going to be verbal. It will be we're going to invoke the destructor. Now, because it really isn't returning anything, it's going to behave just like a constructor and not have a return type. And you can only write one. You can't overload it because the system isn't smart enough to figure out which, which object you want to destroy. But let's do this. Let's just see out point destroyed, and we'll implicitly invoke this. Let me put an end out here, just for using it here in main. So when all is done, I could do this. P1 or rather, I don't need to invoke it, because when we are done here, both of these points are going to echo back that they've been destroyed, because we return 0. You can see the points are destroyed. That one didn't have a new line, so let's do this. Cout end L. Okay. So if you look in your book, they talk about how to create dynamic pointers to it, and then when it's done, we destroy them. So that is a great use of the destroyer, and it calls it automatically when the point is destroyed. Okay, so it's always good form to have the destructor in. And let's see if I need to put anything else in before I go to what I consider a very dangerous thing. But before we do that dangerous thing, let's do another set. Void set x. I'm creating a new method to set x to something. Now you know I can only have a unique method, but suppose I want to set it to some string, like we're setting the point to a string. We can have overloaded methods just like we can have overloaded constructors. So let's come down here, and where shall I put it? I'm going to put it here at the setter. So here's right behind the set x. Again, void point set x string s. This is in case somebody wants to do something like this. I'll come down here and I'll say this. P2 dot set x to 999. Notice it's a string method. So far I only know how to deal with integers. I don't know how to handle a string and convert it to an integer. I never wrote it. I'm writing it now. So coming up here to the set x string, this x, it'll be set to a string cast of our string, and that will look something like this. STOI, which stands for string to int of s. STOI is found in the string method. Compile, run. Come on. Am I being impatient? Run you again. There we go. There. Okay, we set it to 999, and here it comes back as an integer, 999. So now we have an overloaded method here. All right, now, if you follow in your book, when we create these objects, we don't want to clutter them inside a main program. And so many times what we will do is we will take this information, all the prototype information, set it in a header, and then put the actual functionality inside a CPP file. There's no main in it, it doesn't run, but it's the information that the header recognizes. For now, for code blocks, I'm going to take this information and put it inside a header. So in case it crashes, I'm going to put a star slash star and star slash behind and in front of everything. So here's my information that I want to copy. So let me take all of this, highlight it, and I'm going to dump it in a .h file. Okay, Control C, copy. All right, you have to follow this in code blocks. File, new. I selected an empty file and gave it the name point.h, and it put it in a subfolder for me, and it's going to do the same thing whether or not I use file or empty file. So I used empty file and add this project to the, we want to add this. It's going to say what I'm going to call it, point.h. Since it knew that it was a point object, it's going to put it in a header folder for me. I can't change that. Okay, so I'm going to hit save. I'm going to hit OK to select that information. And see what it did? It gave me a header and a grayed out point.h. Come on, why? I don't know. Paste. Zoom in, and good gracious, do a save before the thing crashes. All right, so here's my header file. A trick we do in C++. If I have other point objects, how do we know which is the one I want? How do we know one's not going to clobber another? That I include another file that also has point in there, because then you'll get all sorts of errors saying already defined, already defined. So we put in these tricky words. We will put in a new directive, and we'll say if and def, meaning if not defined, if what's not defined. Well, I'll say point h. There's nothing special about this. It is just a name declaring an area. We make it all in capitals. We make it underscore as reference to the dot point.h. So if this has not been defined already, let's define it. Oops, pound define point underscore h. And this automatic endpoint that it gave me should really go at the very end. And there's the end of the definition. Okay? That way, if I have another thing called point h, it'll do that for me. I've seen this where they put an underscore before and after to really drive it home. Our book just uses the regular point underscore h. Again, I've seen this. So why do we deal with this? Because watch what's going to happen here in main. Because I commented all this out, if I try to compile and run it, it's going to say I don't know what the point object is. Yes, because I blanked it out. But at the top, let's do this. Pound include, and in quotes, point.h. Quote means it's not in a general C++ library, but in our local directory. So if I compile this, and it's still yelling at me, oh, I know why. Because in point.h, we had the luxury when we were here in main of using pound include string and using namespace std. Space. Okay, save, build, haha, all good. Let me just make sure. There we go. Now we run it. And now it's everything we've expected. So when you write objects, the book wants you to save it as a point.h and a point.cpp or whatever it is. I'm going to play around with code blocks a little bit more because it's fighting me as to how to have a separate CPP. It's putting point.cpp here when I try to do it, but I can't recognize the point.h. So I don't want you to have the same problems. Let me be the one to be on the front line, suffer the slings and arrows of outrageous misfortune with code blocks, and then I'll come back and report this to you. So I think we've got everything here. This is a very good start with just the basics of object-oriented programming. And I'm going to leave that in there commented out. But these will get posted, and so will a UML Word file. Okay, that's our lecture and series for now, and then you have a lab associated with this.